Welcome to 9.5 Volume Part 1. This is prisms and cylinders. We're going to start with some definitions. So the volume of a solid is the number of cubic units contained in its interior, and it's measured in cubic units. So area was measured in square units. This is measured in cubic units. The volume of a cube postulate. The volume of a cube is the cube of the length of its side. So think if a side is 4 by 4 by 4, we just do 4 cubed. Volume congruence postulate, if two polyhedrals are congruent, then they have the same volume. Finally, volume addition postulate, the volume of a solid is the sum of the volumes of its non-overlapping parts. So you could break it down into multiple different shapes, find the volume of each, and add them together. So we're going to look at example 1, find the volume of the puzzle piece in the cubic units. Well, one cube is 1 by 1 by 1, so 1 cubed is 1. The bottom portion of this shape is 7 by 2, so it contains 14 cubic units. The upper left portion is 2 by 2, so it contains 4. The upper right portion is 1 by 2, so it contains 2. And then you add them together, 14 plus 4 plus 2 is 20 cubic units. So the volume of a prism, the actual formula we're going to use is volume equals the area of the base times the height. So you find the area of the base, and then you just multiply by the height of the prism, not the height of the base. So B, that's the bottom rectangle is base, and then the height is the height of the prism. For the volume of a cylinder, it's the same formula except area of the base is the circular base, so it's pi r squared. So pi r squared h, where r is the radius and h is the height. So find the volume here. We have a trapezoid. Trapezoid's bases are 6 and 14. The height is 3. The height of the prism is 5, so we'll use that for our final h. So we're going to do 6 plus 14. Times 3 divided by 2. And so the area of the trapezoid is 30. The height of the prism again is 5, so it's 30 times 5. So it's 150 cubic centimeters. Right, the cylinder, the radius is 9, the height is 6, so we're going to do pi times 9 squared times 6. And we get 486 pi cubic feet. So find the volume of the wooden sculpture. Each of the 13 beams are 30 by 30 by 90. So we're going to find each of the wooden beam, and then we're going to multiply by 13. Okay, so the area is the volume is the area of the base times the height. The area of the base is 30 times 30, which is 900. The height is 90. So 900 times 90, and we get 81,000 cubic centimeters. Then we multiply that by 13 because there's 13 beams to get 1,053,000 cubic centimeters. All right, our final example here, find the volume of the solid. So it's a triangular prism with the rectangular prism taken out. So we're going to first find the volume of the triangular prism. So we have a triangle, the base is 10 there, and it's a equilateral triangle. So we're going to find the apothem and then do 1/2 ASN. So the apothem, so our other side is 10, our side down here is 5. We're going to do Pythagorean theorem, 10 squared minus 5 squared to get 8.66. And then we're going to do 1/2 times the side length, which is 10, times 8.6. 6 because it's a triangle. It's 1/2 base times height. We get 43.3. The height of the prism is 6. So we're going to do 43.3 times 6. And we get 259.8 for the volume of the triangular prism. The rectangular prism, the base is a 3 by 3, and the height is 6. So we're going to do 3 times 3 to find 9 for the area of the base, times 6 gives us 54 cubic feet. And we're going to subtract the 2 to find the volume that is part of the triangular prism, not including the rectangular prism. So 259 minus 54 is 205.8 cubic feet. So that's it for volume of a prism and